Today it will be all about visiting the helicopter factory. This factory is where the Mil Mi-28 helicopter comes from. It is a Soviet all-weather, day-night, military tandem, two-seat anti-armor attack helicopter. Let me know in the comments section below the video if you prefer the American Apache or this Russian Mil-28. The price of one Russian Mil Mi-28 helicopter is around $20 million. By comparison, the price of an American Apache AH-64 helicopter is around $50 million. The entire production process of this combat helicopter starts with the computer and the preparation of the material for the main rotor blades. Central to this process is the utilization of composite materials, particularly fiberglass, renowned for its remarkable strength-to-weight ratio. Through a series of meticulous steps, thin glass threads are expertly bound together to form strips, laying the foundation for the spar's construction. To fortify the spar further, additional glass threads are laid crosswise, enhancing its resilience against external forces. This approach imbues the spar with a remarkable strength, capable of withstanding the rigors of flight and potential impacts. The Mil-28 combat helicopter has been developed by Mil Moscow Helicopter Plant and is known by the NATO codename HAVOC. This modernized is called Mil-28NM. It will receive a weapons upgrade capable of firing missiles at all times and in any weather, including at very short visibility. This laser is used to plot the component on the computer. After the production of the rotor blade from fiber, it is followed by manual machining and inspection by factory workers. Glazing of all irregularities is the next stage before the blades are reinforced in special tanks. Maximum forward speed is about 300 kilometers per hour, sideways and reverse speed about 100 kilometers per hour. Since the propeller blades are the main load-bearing surface of the helicopter, a huge amount of effort is devoted to their manufacture. Heat treatment of the material from which the blades are made increases strength and resistance to gunfire. This is followed by the addition of titanium forgings inside the blades. This protects the entire helicopter rotor from the elements. There are also anti-icing electronics built into the blades. Now the production process is being moved to the main assembly hall. Here, the main structure of the entire helicopter is assembled. The engine is then assembled, the main rotor is attached, and then all the electronics, including the controls. Only at the end of the process are the blades, armor, and armament added. Unlike automotive factories, where a number of robots are used due to the need for mass production, helicopters are always mostly assembled by factory workers. You will therefore see a minimum of robots and other helpers. Everything is done by hand. The 5-blade main rotor is mounted above the body midsection. Short, wide, tapered weapon-carrying wings are mounted to the rear of the body midsection. 2 turboshaft engines in pods are mounted alongside the top of the fuselage with downturned exhausts. The fuselage is slender and tapers to the tail boom and nose. It features tandem, stepped-up cockpits, a cannon mounted beneath the belly, and a non-retractable tricycle tailwheel type landing gear. Due to the energy-absorbing landing gear and seats, the crew can survive a vertical fall of up to 12 meters per second. The Mil-28 has a fully armored cabin, including the windshield, which withstands 12 mm armor-piercing bullets and 20 mm shell fragments. The helicopter design is based on the conventional pod and boom configuration, with a tail rotor. The main rotor head has elastomeric bearings, and the main rotor blades are made from composite materials. The tail rotor is designed on a biplane configuration with independently controlled X-shaped blades. This helicopter is manufactured at the factory in Rostov-on-Don in southern Russia. It is equipped with 2 heavily armored cockpits, a windshield able to withstand 14 mm caliber bullets, in-nose electronics. It is powered by 2 turboshaft engines with 2,200 horsepower each. The night attack variant helicopter retains most of the structural design of the original Mi-28. The main difference is the installation of an integrated electronic combat system. Other modifications include new main gearbox for transmitting higher power to the rotors, new high-efficiency blades with swept-shaped tips, and an engine fuel injection control. The pilot uses a helmet-mounted target designator, which allocates the target to the navigator's surveillance and fire control system. The navigator officer is then able to employ guided weapons or guns against the target. The targeting system follows the direction of the pilot's eyes. As a combat helicopter executes complex maneuvers, the turbine shaft of its running engine accelerates to a staggering 15,000 revolutions per minute. Meanwhile, the main rotor must maintain a steady pace of 240 revolutions per minute to provide the necessary lift and stability. This stark contrast in rotational speeds underscores the crucial role of the main gearbox, acting as a bridge between the roaring engine and the graceful rotation of the rotor blades. Much like a gearbox in a car, the main gearbox performs the essential task of converting a high number of turbine revolutions into lower propeller speeds, all while increasing torque. This intricate process ensures that the helicopter can achieve optimal performance and maneuverability, even in the most demanding combat scenarios. However, the significance of the main gearbox extends far beyond its mechanical function. Its failure could spell disaster for the entire aircraft. The failure of the main gearbox is nothing short of catastrophic, akin to the death knell for the helicopter itself. Recognizing the critical nature of this component, engineers have continuously pushed the boundaries of innovation to enhance its reliability and durability. Enter the era of turbo-free engines, each weighing nearly 300 kilograms and installed alongside the main gearbox. These turbo-free engines represent a paradigm shift in combat helicopter design, offering redundancy and resilience in the face of adversity. With multiple engines powering the aircraft, the total engine power is calculated with a reserve, ensuring that even if one engine fails, the helicopter can safely return to base using the remaining power plant. This redundancy not only enhances the safety of the crew, but also increases the operational effectiveness of the helicopter in the field. This attack helicopter has small swept-back, mid-mounted stub wings with 4 suspension units. Countermeasure pods are mounted on the wingtips. The helicopter can be armed with a mixture of air-to-air and air-to-ground missiles, unguided rockets, and podded guns. The Mil Mi-28 Night Havoc are armed with Sturm and Ataka anti-tank missiles supplied by the Kolumna Design Bureau. Up to 16 anti-tank missiles can be mounted on the helicopter. Sturm is a short-range, radio command-guided missile. The Ataka missile's guidance is by narrow radar beam, and maximum range of the missile is 8 kilometers. The missile has a tandem-shaped charge warhead for penetration of 950 millimeters to 1,000 millimeters armor. It has a fully armored cabin, including the windshield. The helicopter can also carry 4 containers, each with unguided rockets or with 5 122 millimeters rockets. The helicopter can alternatively carry containers with grenade launchers, aerial bombs, and incendiary tanks. Mil-28 has impressive aerobatic capabilities, can execute a diverse range of maneuvers, including flying backwards and sideways, as well as navigating ultra-small spaces up to 5 meters in height. These remarkable flight qualities, totaling 28 advantages in total, are the culmination of extensive research and development by the aircraft designers at the Mil Design Bureau. Unafraid to push the boundaries and experiment, these specialists dedicated nearly 3 decades to perfecting the design of the Mi-28. Their efforts have paid off handsomely, as today, the Mi-28 stands as one of the most reliable and efficient attack helicopters in the world, a testament to the enduring legacy of innovation and expertise in combat aviation.
The Sikorsky UH-60 Black Hawk is a 4-blade, twin-engine, medium-lift utility helicopter manufactured by Sikorsky Aircraft. The Black Hawk helicopters are manufactured at the Sikorsky Aircraft Corporation production facilities based in Stratford, Connecticut, USA. Licensed production of Black Hawk helicopters is also carried out in Japan and the Republic of Korea. The unit cost of the Black Hawk varies due to differences in specifications, equipment, and quantities. For example, the unit cost of the Army's Black Hawk is $5.9 million, while the unit cost of the Air Force Pave Hawk is $10.2 million. The price could reach as high as $25 million if just a single helicopter is purchased with a unique configuration. You are now watching a single Black Hawk rotor. This is all one piece, and it's all titanium. The protective elements are very effective. Protecting the crew and soldiers is an essential function of this combat and transport helicopter. A more detailed production process from Bell's helicopter factory will now begin, so you have something to look forward to. Bell 525 Relentless is an American medium-lift helicopter, under development by Bell Textron. The helicopter was being constructed by Bell Company at Amarillo Plant, Texas. The helicopter first flew on 1 July 2015. It is designed to transport up to 19 passengers, more than any existing super-medium helicopter. Estimated price for this great helicopter is around $15 million. The Bell 525 is designed to meet a requirement for a medium-lift helicopter. It will be constructed primarily from composites and metal, and is to be the first commercial helicopter to incorporate fly-by-wire flight controls. It is designed to support several mission configurations, including offshore, search and rescue, and VIP transport. Bell 525 Relentless incorporates a new advanced aerodynamic design for delivering higher speed and range. It is constructed using metal composites and features an all-composite, 5-blade main rotor system and 4-blade tail rotor. This video footage is from manufacturing process of Bell Huey-2 helicopter. The Bell Huey-2 is a remanufactured, modified and re-engined military UH-1H, including an Allison turboshaft engine of 1,343 kilowatts, a vibration reduction system, infrared countermeasures and a night vision goggle-compatible cockpit. Currently offered by Bell. The upgrade is intended to provide improved performance over the standard version. The helicopter can be configured for a variety of missions, including troop transport, cargo, search and rescue, special operations, disaster response and firefighting. The UH-1H Huey-2 modernized helicopters are used by a number of armed forces worldwide. Combining a modernized airframe of the basic UH-1H helicopter and Bell 212 components, the OEM standard Huey-2 upgrade offers lower direct maintenance costs and greater mission flexibility. It is equipped with new features such as increased horsepower, crashworthy seats, multifunctional interior, new wiring and digital cockpit. The helicopter has a 2-blade, semi-rigid main rotor and a 2-blade tail rotor. It is also equipped with a new skid-type landing gear. It has an empty weight of 2,552 kilograms and cargo hook capacity of 2,268 kilograms, and can carry a useful load of 2,210 kilograms. The internal and external maximum gross weights are 4,763 kilograms and 5,080 kilograms respectively. The cabin has a volume of 6.2 cubic meters, and its interior can be configured according to the mission requirements. The Huey-2 is operated by 1 or 2 pilots, and can accommodate up to 14 personnel. The crew section is equipped with jettisonable doors and new wide windscreens. The wide sliding doors of the cabin facilitate easy loading and unloading of cargo. 4 large windows fitted to the cabin offer improved visibility. The large, flat cabin floor area can be reconfigured with multiple structural assemblies and hard points to provide multi-role flexibility. The helicopter can be provided with 3-place litter, high skid gear, cargo hook, hoisting, and armor solutions. The Hui-2 offers improved safety over the standard UH-1H and comes with safety equipment, including jettisonable crew doors, new crash-resistant fuel cells, wire strike protection system, rollover bulkheads, auto-rotation, and transmission system with chip detection and debris collection. The helicopter is equipped with several navigation and communications equipment, including UHF and VHF communications systems, intercom, control head, automatic direction finder, compass, KLN 900 global positioning system, transponder, and emergency locator transmitter. The pilot's instrument panel consists of radar altimeter, Ki 229 radio magnetic indicator, pictorial navigation indicator, and turn and slip indicator. Now let's move to Bell's Textron Canada. Learn more about custom paint job here. Now let's move to Bell's Textron Canada. Learn more about custom paint job here. This is how it looks like when Bell 505 helicopter is painted time-lapse. Helicopters are normally painted every 7 to 10 years, and as you likely suspect, they have to be stripped of the old paint before any new paint can be applied. After the old color is stripped off, a primer is applied, then the paint itself. The process of painting a helicopter can last from 3 to 9 weeks. On average, the typical helicopter paint job takes 6 weeks. The Bell 505 costs between $1.2 million for 2016 model and $1.8 million for 2022 model. The value of a Bell 505 can vary, even between two aircraft with the same year of manufacture. With a speed of 125 knots, which is 232 kilometers per hour, and useful load of 1,500 pounds, which is 680 kilograms, the Bell 505 is Bell's new 5-seat aircraft designed for safety, efficiency and reliability using advanced avionics technology. Initial assembly, flight testing and certification started in Canada, while the factory is being built in the US. The Bell H-1 Upgrade Modernization Program is the United States Marine Corps' program to develop military helicopters to replace its aging fleets. The contract was awarded in 1996 to Bell Helicopter, the original manufacturer of both aircraft, to design the new airframes as modernized attack and utility helicopters with considerable design commonality, to reduce operating costs. The stated mission of the H-1 upgrade program is to resolve existing safety deficiencies, significantly improve operational capabilities, and reduce life cycle costs. Commonality between aircraft will greatly enhance the maintainability and deployability of the systems with the capability to support and operate both aircraft within the same squadron structure. Reduce logistical burden, maintenance costs, and personnel requirements are possible by the increased commonality of the two airframes, as well as increased reliability of individual components. Test simulates typhoon-like conditions, and these workers are testing water intrusion of the Bell H-1. Ensures aircraft is completely sealed, watertight and ready for operation in adverse conditions. If the water gets into the cockpit, this helicopter must be repaired immediately. No water may enter the naval helicopter. This is aeronautical accessories under the Bell Helicopter brand. This company is the market leader in helicopter accessories. With the ability to design, certify, manufacture and market a wide selection of quality helicopter parts and accessories, Aeronautical Accessories can provide you with a customized solution fit for any mission. Located in Piney Flats, Tennessee, Bell's Aeronautical Accessories brand offers high-quality windows, interiors and trim, landing gear, and many other product categories for a variety of helicopter manufacturers. As the world's largest rotorcraft parts and accessory provider, Bell's goal in offering aeronautical accessories branded products is to supply reliable aircraft accessories that make a difference in every flight. From new, lightweight, fuel-saving skids, to improved visibility windows, Aeronautical Accessories branded product solutions are designed to help pilots fly more safely and efficiently, while tailoring the aircraft to a specific mission. The brand currently offers more than 4,000 unique part numbers, and 1,200 supplemental type certificates. The future of vertical lift has taken shape, as a full-scale mock-up of the Bell V-280 Valor. The Bell helicopter team solicited the prototype services of Roush Enterprises to create a full-scale mock-up of the medium-class helicopter. Roush used the Bell aircraft design and adopted it for the mock-up in order to meet business development requirements focused on the U.S. Army customer. The mock-up is more than a marketing tool. It helps developers visualize and understand the value of certain requirements, bringing the digital design to a 3D reality that allows soldiers to climb on and experience. Slightly bigger than a Black Hawk, the Valor will carry a crew of 4 and 14 combat-ready troops. It will also feature a triple redundant fly-by-wire flight control system. The aircraft is the third-generation tilt-rotor aircraft that improves upon the operational design of the V-22 Osprey. Built by Bell and Boeing Company. Bell says the Valor will have the ability to self-deploy up to 2,100 nm and cruise at 322 miles per hour, twice the range and double the speed of any existing helicopter. Rather than tilting nacelles like the V-22, the Valor's rotors tilt independent of its two engines, which allows for variable pitch and better stability in hover and transition, the company says. If you are interested in other factories where helicopters are made, you can continue to other videos on my channel. Please write me what other video you would be interested in. I am currently trying to prepare other similar videos on the production processes of fighters and large aircraft. I like Gripen fighter jet, Apache helicopter and other military vehicles. I uploaded videos from Bombardier Factory, Cabri G2 helicopter factory and Airbus A400M production line.